Today on this chilly morning in Melbourne, Australia, we're going to look at the R1 rotary chuck from Atomstack. This is the final piece to the laser that we've been reviewing. Let's go. Okay, so I just received the last part of the equipment that Atomstack asked me to review. This is called the R1 rotary chuck. I'm new to rotary engraving, so I'm very excited to open this up. We're going to do it right now. I'm going to bring you along to see what's needed to set this up and get this working. So let's go to the table, let's see what's in the box, and let me show you what this is all about. All right, so let's see what's inside this box. With a lot of the Atomstack gear, it's really well packed. Love the foam, love how it's all presented. Let's see what we have here. So we have these things first. I believe these are the risers. So that's two of the risers. We'll see what they have to do. There should be a third one around here. We have the first rotary assembly. This one right here. Looks snazzy. We're going to address that in a small while. Let's see what else we have here. We have this piece. It looks like a roller gantry. We'll work out what this piece is all for. We'll go through the instructions. I believe these would be some of the ways that you place a piece of material on the chuck. We'll address that in a bit too. Tools, and that looks like it is a cable. What else we got? A plastic micrometer. We'll use that to work out the circumference of what we're going to work with. A nice little bubble level. They come in very, very handy. A measuring tape. I'm seeing a theme here. This piece right here, at the rate these birds are, we might get a kangaroo coming in saying hello to us and learning all about laser engraving. There's some other stuff here. We have a roller assembly. So we can put oversized pieces on this, and I've got a feeling, yes, that will roll. My critics outside. You're doing it wrong, Gil. And I think that's it. Yeah, that's everything that's in here. Really well, nicely put together. All right, let's get this out of the way and let's start putting the assembly together. All right, I got a little confused because I was like, hang on a second, I've only got 2 of these pieces. I need 4 to raise my laser up all the way. So if I bring this back here and just rest it on the top, I actually found them. They're right under here. So again, great packing and a very clever way of getting all these pieces together. I just couldn't find them before. So we now have all the pieces. So let's get cracking. So these are the parts we need. I'm going to open them up as we go along. The first piece we need is this little stopper that I believe will go in here somewhere, but we'll get to that in a second. We also need those jaws. So this is the piece that I was telling you was reminiscent to me for like a lathe. This is a 3-point chuck. And if I'm correct, yes. When you take this little disc and roll it back, you can see it actually opens up and closes. So we need to have something hold the piece in the middle, and that's what we're going to apply right now. So oh, look at this. I did this instinctively without even realizing. This is a clamp, so we can also change the angle, move it to whatever angle we need, and then for demonstration, I'm going to move it over here, lock at that in that angle. So it's pretty intuitive, which is really nice. I can see why they now want us to have the little bubble, because if we want to get that straight, if I loosen this up and I move the bubble over the top, I hope you guys can see that it's right in the middle. I'm just going to give it a slight adjustment. There you go. So you can see that bubble is considered straight or parallel to the table. So that's very handy to have. So the next part are these, and these are those kind of soft jaws that will clamp on different angles to something that's cylindrical. So we have a few of those. And we also have a second set. I want to show you the difference. So we have an L bracket here. So if you see at the bottom, that's what actually will, I believe, go around, let's say, the inside of a curve. Or we have these ones here, which are stepped at the same time. So we can actually hold something from the inside as well. So let me just show you the differences. We have two different clamps. One, on both of these, they're curved on the outside. I don't know if you guys can see the curve. And that can be used, if you had something cylindrical, you can actually use that outer curve, push the clamp onto the surface like that and hold it. Or alternatively, especially with the stepped one, you can actually mount it from the outside as well. So you could mount it on that outside curve there or there. So by having two sets, and these are made out of plastic, then you know, they're not going to damage anything that you've got in your chuck. But having these two available makes things a lot easier. You're also given one other option to mount objects onto that 3-jaw chuck. And so these things are called hexagonal jaws. And the idea with these is that you mount them very similar way, but what we actually do is these get screwed straight in. And if you've got a hexagonal piece, the idea is to actually have these placed all in the same kind of direction. We'll just temporarily mount them in here this way. I'll turn it to the side so you guys, actually I'll turn it around. So if you had a hexagonal piece, you could slide that piece in, secure it, and still be able to open up those jaws slightly, putting pressure on that piece from the interior. And you can see that these parts are actually rounded. You can get a good surface area around that piece and be able to hold it as it actually turns when you're doing the engraving. So those are 3 ways to be able to mount your material to this chuck. It actually gives you a huge latitude to be able to bring in pieces. So that's a trick that I learned when I was learning to lathe and mill. So the fact that they're using older techniques to be able to allow you to work with larger variants of materials are fantastic. We're going to put the larger set of jaws on. So I'm going to move those back there. We're going to use these larger jaws. And I'm going to go and use the tools that were in the toolkit. And in here is a whole bunch of screws right here. So these screws go into the mounting points, and each one of these has 2 little holes right there. Let me see if right there. So what I'm going to do is I'm going to drop in a screw on each one. So I've got 2 of them here. I'm just going to turn this so you guys can see what's going on. And then depending on the orientation, if I want to clamp a piece of material, and I'm trying to see, let's use one of these. This is a circle, right? I have 2 choices. I can clamp the piece of material on the inside, or unfortunately this is not open, but if you can imagine, I can do it on the outside. Some of this comes just from experience. There's no problem with putting your jaws onto the chuck and then deciding you need to change it. This is a brass piece, so it'll have some resilience to it. To just make this a little bit easier, we're just going to open this up a little bit. Again, when you try to do this for the very first time, especially to a camera, and try to get your body out of the way, it's not always the best way. If I got the right key, it also helps. That's better. And I'm just going to tighten, not even, just finger tight. I'm not going to put a lot of pressure on it. I don't want, these are just, what I don't want to do is either strip the thread in the brass pieces or damage the plastic. So I'm going to do that for the next one as well. Now they only give you enough to put one set on at one time. I would have liked to have seen a second set of screws in this kit, only because my experience, you always lose the screws. They're small and they get thrown around when you're in a hurry. So one of the things I'm going to do is source out some more screws so that I can actually have a backup set of screws. Last two coming in here, just resetting and also putting those screws in. I want to show you guys exactly what I'm doing here. I could have set this up beforehand. See, there you go. That's a screw just jumped out. But what I was going to say was, I want to actually show you exactly what I do, because when you guys invest your time into a kit, I want you to understand what's involved. Now, I could have got someone else to set this up for me, make myself look really, really good, and we could just talk about how this works, but I think that doesn't really give an honest appreciation of the process. So that's why I do it this way. Now I have a piece that can be locked in or opened up as far as wide as I'd like. Okay, now that we've got those jaws in, and before I do a test, I want to show you exactly how this works, and I want to make sure I get the right angle here. I have a takeout container. You might have got something like this similar when you've got some food. What I like about this is it's going to show you exactly what's going on with the jaws on the inside. So let me bring this across. I'm going to place that in around about in the middle. I'm going to hold it this way so you can see what's going on, and I'm going to expand the jaws. What I don't, and as I'm expanding them, you'll see those jaws will go out, and they will eventually make contact with the inside of the material. So if you can see there, and as I just turn it around, I don't know if you guys, yeah, you guys should be able to see that. I'm going to turn it there. Can you see that it's a little bit out? Like it's kind of rocking. And I want to show you how to fix that as well. But in theory, I wanted you to see exactly how this works. And you can do that with this plastic container. So I'm going to loosen that up a bit so I can take that back off. And what I'm going to do is, to make sure that all of the contact of the jaws are equal, what I tend to do is I push this all the way up to the edge of the piece, and then I actually turn it all the way around. I'm going to point it to the camera so you can see this is out. I'm going to move this down just a little bit. There's a very little pressure here, so I can adjust as much as I want. Let's see, I'm going to do the same thing here. I'm going to bring it around again. I'm just going to adjust this slightly because to me it's a little bit off. So you can see as it moved, it kind of jumped. So I'm just going to put a little bit more pressure on there now. Move it across again. You can see it jumped. This type of container also is flexible, so it's not solid, so it may jump a little bit as it moves. But if you take a look now, you can see, and if I do it this way as well, I just turn it by hand, there is a little bit of play in there, and that's because the pressure on this side and on this side, it's bulging out the piece, but we actually have a relatively straight piece, meaning that when the laser is engraving on the top, on a hard solid piece, there's no flex. So what we'll actually have is a very clean engraving. So I wanted to show you that as a practical example of what's going on the inside. Alternatively, if we do it the other way around and use the jaws on the outside, we bring it in, and it's easier on the outside because the L will self-grab and self-level. We have now the piece in there and also levels. So these are just an example of how this mechanism works. If you're new to rotary engraving or to using something like a 3-jaw chuck, just wanted to share with you exactly what happens so that you can get your material in, leveled up, so we can take, as I said before, move it, lock it in place, and now we are ready to engrave the outside of whatever shape it is. So the last part we need to install is this thing here, which is called the column support assembly. And if you see at the bottom here, see right here, there's a kind of a dovetail joint that matches the piece in here. So this is really easy. We slide that piece in like that, and then there's just 2 screws here that allow us to tighten it up and lock it into place. So if I went and got my takeout container again, and I place it, let's do it this way so that we can actually put it on the surface here. So we take it all the way out. I'm going to line it up so it's kind of as round as possible. And then I can actually slide this piece up. And it should end up right in the center of my piece. And this is also a good way of checking. That looks pretty good. You can see there, once it's touching, that will actually support the piece so that when it's rotating, it doesn't flex out. So again, we have that piece moving. There's a little bit of flex here as I'm doing it, only because of the nature of this material being plastic. But again, I wanted you guys to see, you can see where that kind of suction cup in here is actually supporting the material. So once that's done, you open up the screws, slide it back, unlock, take your material off, and that is the setup of this 3-jaw chuck. All we need to do is take it over to the laser, and I'm going to do that. I'm moving on to the roller assembly here, and as I actually brought it out, took a closer look, I noticed that right on here it says R2. So if that's the R1, this is the R2 roller assembly. I did go online, couldn't find any documentation on the R2. I believe it may be superseded with the R3 roller, and I did take a look at those instructions, but we're going to move through and I'm going to explain to you all about this unit. This unit's designed for pieces that can't go onto the rotary chuck at all. So if you can't fit a piece because it's too big, and in fact, in this case, I'm going to take this piece right here, I'm just going to place it. It's got some nuts and bolts on there, and just move it manually. You can see that if you can get the focus length, excuse the noise because there are nuts and bolts everywhere here, you can actually see it's moving around. For the demonstration on this, I'm going to use a paper towel holder just because it's light, easy, but you can see here, again, I'm just going to move it manually, and you can see the idea here is that it actually turns the piece around. This gives you great options for a whole bunch of different material. It also comes with this piece right here, which I was like, what's this piece all about? And I realized that if you have an extra long piece, the idea here is, depending on what the height is, and you can adjust it by moving the pieces up and down with some hex screws. If this piece was a little bit bigger and we had adjusted this up higher, the idea is to keep it all parallel. So this is a piece just like the support piece on the 3-jaw chuck that I showed you before. It's there to support a long piece so it doesn't move as it's being rotated through the engraving process. You do have some options with this piece, just like the screws on the support piece. If you turn this around, and there you go, model R2. You have a few screws here that you can pull out and actually change the distance of one of the support pieces. If I tilt this up, you can see that this piece can actually slide forwards and backwards, depending on what you need. So we're going to just make it a little bit smaller for that paper towel roll. I'm going to actually move it as close as it can be. I'm going to turn this around and just see if I can line up. Again, it's hard to do without getting in the camera's way. But I'm going to put a screw in here, just nice and gently. And I'm going to put a matching screw and lock that in just a little bit closer. So again, you've got great flexibility with this kit, which is something that I really like. You know, you might be doing something that's a little bit smaller. If you take a look now, though, we've got a bit of a problem. There's a lot of loose tension on the motor here. If you see here, it's not touching those pieces. So again, there's a screw here that you can loosen up that will allow you to slide the motor across into different positions so that you can get enough traction going. And I just need to slide that right across there. I have enough traction on that last pivot. I don't need it on both because they're linked, but in fact, in this position, I'm hoping you guys can see this, I'm actually touching the sprockets both on this one and this one, but I actually have to move it all the way across. I'm putting a little bit of force in there just to hold it into place. And I'm going to now just nip that up with the screw. There you go, camera's going, I'm dropping everything. And what I like about this as well, just to give some feedback of what I really enjoy, is those screws are actually knurled, so I don't have to go and get a Allen key from my kit and have to fiddle around with this. I like the fact that I can just do it finger tight, quickly. I've adjusted it. So now when this turns, or this turns as well, I place the roll in there and I have a really good area that is supporting the material that I'm using, as well as moving it around. I can do the same thing here, unfortunately using Allen keys. So I can open this up, change the height so that if this piece was longer, we could have it at the same level, which again gives you a great option because this piece is not that long and we're not going to have the piece flexing or bowing as it's being rotated. We're going to leave that piece right there. You as the operator can adjust this so you can get a perfect support. That's all that's really needed to be done with the R2. As I said, it comes pretty much ready to go outside the box. I just want to show you some of the options. We're now going to move over to the laser. So setting up the R1 rotary chuck to be used with the laser, we're going to use the Atomstack Maker A30 Pro, which I reviewed in a previous video, and it actually is part of this series. If we place the rotary chuck there, you can see that even if I brought this up a little bit higher, we haven't got anything to work with. We have no room to make sure the focus works. So this is where these things come in. These happen to be lifts for the base. I'm going to show you how they work. But before I go over and apply them, I want to show you here that there's a groove in there. So the foot on the machine fits into this groove, and there's a little screw. Don't know if you guys can see that, but as I turn that screw in, it just basically locks the foot to the base. Some people will say, hey, you know what, that's really cool, Gil, but what if I've got a piece that's a little bit bigger and I need a little bit more space? Well, they've even thought about that too. There is a nut embedded here. I'm not sure the size of that, but I'm sure you could get some sort of piece to lock in so you could extend the height. I'm going to remove the chuck because I don't want to damage anything. I'm going to take the first one and I'm going to do this single-handedly. So let's see how this goes. So let me see what's going on here. So this happens to be a little bit higher because if I take this screen off, you can see that the control box is right here. So let's put the screen back here. I'm going to just move it across to the side here. Could be just simply that the table is a little bit out. But by moving it across to the corner side, I'm actually able to get the same level. So we have no lopsidedness. We've raised the laser. And now, when I place the chuck in the area, we have enough room to focus. Now that we have the laser raised and the chuck temporarily in a position, we need to connect it, and Atomstack gives us 2 cables. Now, it comes with 2 separate cables. One is a white cable, one's a black cable. The white cable is designed to work with the Atomstack range of lasers, so that's the one we're going to use. The black cable is a compatibility cable for anyone using a different type of laser. So depending on if you've got the unit and you're using it with a different laser, you have both those options ready. So I've removed the white cable, which is the one that will connect to the Atomstack laser. What I'm going to do now is I am going to physically hook up the rotary attachment here to the laser and run a test. So the very first thing I need to do, and I'm going to bring this up higher, is if you turn the unit around, you can see there is a area here where the cable matches. So we have a male pin to a female pin. You can only put it in one way, but it kind of slides in there. And unfortunately, every time you want to use this attachment with the laser, you're going to have to go through this process. At the other end is a 2-pronged male adapter. I'm just going to put this one back down. I'm just going to leave it facing the camera. And we actually need to attach this piece to the controller or the extension cable that runs the machine back and forth, and that's the Y-axis. So what I'm going to do is, it's on the side. I'm going to leave the laser here. We're going to bring the camera around. I'm going to show you how I do that. Let's show you how to do this. Just squeeze it on both sides. I'm going to move that cable just a little bit out of the way. And this cable, your first intention is to kind of plug it in here. We don't need to do that. What we do need to do is line it up and just plug it in together like that. As I mentioned before, every time you want to use this, you have to go and unplug it from that motor that controls the Y-axis. And you need to do this as well depending on what unit you want to use. So if you want to use the roller unit, same process there. Now that we've got this all done, I'm going to turn around the chuck and we're going to run a quick test to see if it all works. So I just want to show you now that I've kind of connected this cable up and I realize it's over the top and there's a risk that when this moves, it might catch. I don't like that at all. So I'm going to disconnect it from the rotary. I'm just going to tuck it underneath, and that way there won't be any risk during operation that the cable might get caught or snagged. I don't want to permanently attach the cable to the unit. If maybe I am going to do hundreds of thousands and tens of thousands of rotary pieces and this becomes my rotary kind of machine, yeah, absolutely. But I love the flexibility, and I have plans of exploring exactly what this Maker A30 can do in the future, so I want that flexibility. I just want to be aware of where the cables are. Now that we have the R1 rotary attachment connected up to the laser on a physical level, we need to do the same thing now with Lightburn. This basically just means setting up the rotary within the Lightburn software, and thankfully the guys at Lightburn have made that incredibly easy. So the very first thing we're going to do is go to Laser Tools, and there is a rotary setup option here. We're going to pop that open, and it brings us a little pop-up menu with a bunch of different options. The very first option that we have here is whether or not the rotary type is a chuck, which is what we've set up, or a roller. And what's great about this is you can see in the image here, it changes depending on which one you're going to use. We have both, but we're going to set up the chuck one first. So all we're going to do is choose that option. We have enabled rotary here. Normally it's defaulted off. What that basically means is, as far as Lightburn is concerned, the rotary is not attached, and basically it's kind of like the master enabling switch for a rotary setup. So if I were to try and get my laser to home right now, it'll send more current towards the stepper motors to physically move the gantry back to the home position. We don't want to do that. If you happen to do that accidentally, your rotary will kind of jump because there's more signal or more current going towards it. So let's enable the rotary there. And then we have this option here that says mirror output to rotary. Depending on how your laser is configured, especially if you're not using a Atomstack laser, you may find that the images that you're engraving may come out backwards. Now there is an option in Lightburn to do that on the image layer itself, but if you find you're getting results that are the opposite to what you're expecting, one really easy way to make sure that you're getting those images around the correct way is just basically to mirror that output to rotary. That happens to be a physical thing depending on the cable and the cabling on your laser. So if you set up your rotary on your laser and you find that you're getting results that are backwards, all you need to do is turn on that mirror output to rotary one time. I'm not too sure what's going on, so I'm going to leave that off at this point. The final setup for the rotary before we actually can do a job and test this out happens to be how many millimeters of rotation you want. And on this, the test I was given was 160. But there's another factor we've got to take into, and that happens to be the diameter of whatever the object is that you want to engrave on. Now, if you happen to hate maths, this might be a little bit taxing in the sense that we're going to have to go into kind of the mathematical world. I'm going to go through how you're going to do that in just a moment. But again, the guys at Lightburn have tried to make this as easy as possible. The object diameter is the distance across your cylindrical shape. And I'll show you exactly how to work that out using some of the tools in this kit. But what I want to show you here is that when you put in your dimension, so let's say it was 25 mil, the circumference, which is the full area around your cylindrical object, changes. So if I were to change this to 100, you can see down here, Lightburn's doing the math to work out exactly what needs to be done. So all we need to really do is work out that object diameter. I'll show you how to do that in our next step. The very last thing, I'm going to change that to 50, but the very last thing I want to show you here is your rotary access. And that's all about where we've actually plugged in the Rotary to. In this case, with the Atomstack Maker A30, we're plugging it straight into the Y-axis. So I've selected the Y-axis here. If you're going to change it to the Z-axis, the up and down height, if that's what you want to do, you can plug that in that way. Or alternatively, there's an A-axis, which is a dedicated rotary axis if your machine is wired that way. In the end, once we've got this all here, we want to test the machine. So I'm going to just slide the laser head out, and I am going to hit this little test button right here. If everything is working, we should have movement on the Rotary. Let's see what's going on there. And we do. We actually have everything moving as it should. So it's doing a full test around and coming back. So I know now that we have everything set up to do our very first test burn. All right, I'm just going to turn this off so you guys can hear me. So we're going to use this paper towel roll just for our first test, and I want to explain to you kind of some of the mathematics behind how you're going to set up your Rotary tool, or rotary tool, I should say, so that we can actually get the results you want. So as I showed you guys before, you have these little plastic calipers. You might have a digital set that makes it a little easier. It's been a long time since I've seen a manual set, and if you do get this kit and you want to use them, the little trick here is that when you work out your distance between something, there happens to be a little gauge up the top here, and depending on, or we will use the mill one here, depending on where it sits and it lines up, it works out exactly the measurement you want. Now, if you really want to use this and you want to become a master at this, there are other videos around that will teach you exactly what you need to know to use these manual ones. I usually use a digital pair, but I am going to use what came in this kit, which is the distance between two centers in a circle is what we want to measure. So we're going to take the calipers and I'm going to place them very gently because this is a cardboard tube, and I'm going to read the distance here, and I'm going to work out. So if I need to look at this, guys. So if I do this way, it looks like it is 35, 36, 37. It's between 37 and 38. 37.2 is the distance around that. I'm going to take that back to Lightburn, and we're going to work out the area that we can actually engrave on. Why this is important is that if I take this piece of paper and wrap this around like that, and I've cut this out beforehand, so it's perfect. If we were to take a cylinder and put it flat on the laser, this is the area that we can work upon. So if we were going to, let's say, laser this flat, we could put that into the laser here, and everyone's had the experience of working with flat areas. The difference is with the rotary as well as the cylindrical object, just imagine that flat area is wrapped around. For the experiment, I'm actually going to tape this piece of paper onto the tube. We're going to see what result we get. What I've actually done here is I've changed the orientation of those jaws because the tube was too small to be grabbed on the outside. So this is a great example of the flexibility you can use with these jaws. We're going to grip it from the inside. So I'm going to close this up all the way. Then I'm going to place the tube with the piece of paper over and then gently expand it out. Because it is a cardboard tube, though, I can make it flex. So I'm hoping that's not the case, but I do want to make sure that when it turns around, and I've left this part so we can visually see kind of where the rotation is. We'll start over here. The next thing I need to do is make sure that it is parallel with the surface. So I'm going to take my little bubble, and you can see here that it's out. So I am going to loosen up that piece at the end and just bring it up. Tighten that. That's now parallel. And for this test, I'm just going to try to get some text across that piece of paper. I'm probably going to start it a little bit over here and then hopefully move across this way. Now that we've actually set up the laser with the risers, the focus area is a little bit too high, so I just grabbed a quick piece of 2x4 just to raise the rotary tool. I'm going to place it below. That's going to give us enough space to be able to focus the laser, as well as no movement in the rotary. I'm going to undo this now, bring it up as high as possible, lock it. Now, I'm going to do this with two hands, so if I get in the way of the camera, I apologize, but I'm going to bring my tool, my focusing tool. There's two ways that you can use it. We leave the laser window, so I just need to slide this down, and I'm going to take most of the weight so that it doesn't crush the tube. So what I'm going to do now is I'm just going to undo that screw that was holding it up, and I'm just going to make sure that it gently touches. And I'm going to tighten it up and gently remove the piece. So actually I need to make sure that it got a little bit caught on the outside window, so it wasn't as close as it needed to be. I just double checked that. That is as focused as I can get it. I think that's pretty good. I'm now going to turn the machine on, go back to Lightburn. Okay, we're now back in Lightburn. I need to put some sort of test together. So what I'm going to do is I'm just take some text. How about we say R1 test? I think that's kind of cool. Now you can put this anywhere you want, because what we're going to do is we're going to change where the job starts in the laser tab here. It says start from. If we use user origin, and the origin job for the job is at the lower left-hand side as it is here, it's going to move the laser head there beforehand. We're actually going to go to current position, and I'm going to go and take a look here and do my very, very best to make sure that the laser is as close to the job right in the middle. So I've just done that, I've eyeballed it. I'm going to go to my cut layer. I've set up the speed and power for a test using a little heavier paper. So I'm going to try this out right now. So I'm going to grab my safety glasses. I'm going to put them on, and I am going to run this job. And so you can see the result here. I did obviously burn through the paper. This laser is quite powerful, and this is just a normal sheet of paper. So you can see we've lost the E, we've lost the R, but you can also see the result. If I'm just going to wiggle this off and bring it up to you on the camera, you can actually see the result. We've actually got that along. I did do a quick test just to make sure the spacing was all right here as a line, but you can see this is the result we got from setting up the Atomstack Maker R1 rotary chuck straight out of the box. This is not an area that I've done a lot of work in before, but this is incredibly exciting to explore this in upcoming videos. To use the roller, it's exactly the same thing. All you need to do is change out the cabling, have it hooked up to your Y-axis, and then place your item on the roller, check the focal distance, and then we have an extra step of going into Lightburn and changing that setting. Let's go jump over to the studio, and I'll summarize what I think of this R1 rotary chuck. So we've been testing out and setting up the R1 rotary chuck. I've got to check this out because this is a kind of a big name. So this is the R1 Pro multifunction chuck and roller rotary, basically for laser engravers. So from now on, I'm just going to call it the R1. The R1 rotary is a great addition to your laser, allowing you to process materials in a completely different way that you might not be able to do in a conventional flatbed laser. What I really liked about this is the super fast setup. You just have to add a few little bits and pieces to extend the height of the platform, and you're ready to go. It's incredibly simple for you to set this unit up in your laser and break it back down again for conventional use. Now, the R1 has been designed to be used with the laser engraver range from Atomstack, but I don't see any reason why this accessory can't be used with a similar design. In fact, I'm going to look into this a little bit further to see what machines they're compatible with. But because of its easy interface and setup, you should be able to use this with any existing open platform laser. In fact, I look forward to trying to use this accessory on some of my other lasers. Keep your eyes open because I'm going to share those results with you right here on the channel in the future. The R1 is actually a great accessory for marking cylindrical objects. And in the time that I've been setting it up, I've actually started thinking about projects that I'm going to explore in the future with the ability to use this chuck and roller option for my laser. So again, keep your eyes open while I share some of those projects in the near future. One of the things that I really like, I love how this unit integrates directly into Lightburn. This is awesome, not just because I'm familiar with Lightburn, but it means anyone already familiar with the Lightburn environment can start getting results really quickly. In fact, it shows how manufacturers of this equipment are now adopting Lightburn as their environment, not just for their lasers, but also for the accessories that they're offering. I really like the fact that we were able to get the results we just got very quickly thanks to the integration built in from the Lightburn environment. If you want to know a little bit more about the Atomstack R1 rotary accessory, go check the link below. I'd like to thank Atomstack for sending me the R1 so that I could put it together and review. While I'm relatively new to using rotaries, as I mentioned before, just putting it together has now got my brain working on the future projects that I'd like to use the rotary for. And I'm really looking forward to being able to explore different projects. Some of them might not be as traditional as you think, but as I go and explore the uses for the rotary accessory, I'm going to bring you guys right along. So keep your eyes open, and we're going to explore what a rotary can do for your laser, as well as being able to set it up and get the results you want by interfacing that with Lightburn. If you're interested in getting your own R1 rotary accessory, go check out the links below. I'm going to put a link to the information page on Atomstack's website so you can get your hands on this rotary accessory and start exploring what rotary can do for your future laser projects. So till our next video, check out some of these tutorials and laser-based project videos right here, and I'll see you on the very next laser adventure here on the Laser Livestream. Go make something amazing.